Hi friends, welcome to another session of BGP. My name is Sandeep and I'm going to talk about um, how BGP is gonna process uh, next hop IP addressing. Okay, so let's jump quickly and see what we have got today. Okay, so today we are gonna discuss BGP next hop processing. Let's understand this topology. Let me just quickly take a screenshot of this. Okay, all right. So we have got this topology today, and you could see that we are running three routers here, router 1, router 2, and router 3, which are in autonomous system 100. Then we have EBGP pairing here between router 1 and router 4. This is our EBGP neighbor, EBGP, whereas we have IBGP between router 1 and router 2, and IBGP between router 2 and router 3. Okay, so what we are going to do is that we will advertise a route on the router 4 with IP address 200.0.0.1, and we are going to see what will be the next hop IP address. When router 1 learns this route, what will be the next hop IP address, and when this same route is getting advertised to the IBGP neighbor, what will be the next hop IP address. So the first verification we will do is that how IBGP neighbor is going to process the next hop IP address. That is the first scenario we are going to test. To test this, what we will do is we will advertise a network with IP address 200.0.0.0 through EBGP. We are advertising it here. This route has learned on the router 1, and now it is going to send this same network to its IBGP neighbor. So we are going to test this one. So basically what would happen is that when this route gets advertised, right, so it will say that the next hop IP address is 10.1.4.4. Okay, so this router here will show in its routing table 200.0.0.0. If it wants to reach, it needs to send the packet to 10.1.14.4. Okay, so when this router sends the route to its next router, to its IBGP neighbor, what it will do is that it is going to use the same IP address as its next hop. So what would happen is that on the router 2, the route 200.0.0.0 will be learnt, and the next hop IP address will be shown as 10.1.14.4, 10.1.14.4, which is this IP address here. And router 2 doesn't know how to get to this IP address. So when someone from router 2, let's say I have a host here who is trying to reach to this 200.0.0.0 network, when he does a ping or trace route, the packet comes to the router 2, and router 2 does a routing lookup, and he will say that, okay, to reach this 200 network, I need to send a packet to 10.1.14.4. But router 2 doesn't know where is the 10.1.4.4, and it's not going to send the packet to router 1, and it's going to drop. All right, to fix this problem, what we will need to do is that we will need to use a command called next hop self on the router 1. Okay, so what we would do is that we will do next in the BGP process neighbor 10.1.12.2, and then we'll configure it as next hop self, so that when the packet comes here, when the route comes here for 200.0.0.0, it is going to change its next hop IP address with this IP 10.1.12.1. And what would happen that when the route comes to 200.0.0.0 on router 2, instead of getting this as its next hop IP address, it is going to use 10.1.12.1 as its next hop IP address, and the reachability issue will be fixed. I hope this brief is understandable. So to make it more clear, let's jump onto our configuration and we will verify that. So let me jump onto the router 4 now. I have this topology here. Let me jump onto router 4. Okay, so this is my router 4. Let me minimize this so that we could verify along. Okay, so we have this router 4 here. What I will do is I will execute show IP interface brief command, exclude unassigned. Okay, so we have this IP address on router 4. Where is my router 4? Okay, this is my router 4. Let me drag it here. So you could see that I have this IP address 10.1.4.4 on fast Ethernet 0/1. Okay, and I have configured the BGP. So let me just quickly check my BGP configuration. The BGP configuration is very straightforward. I'm in the autonomous system 200 here, BGP autonomous system 200, and we have the neighbor 10.1.14.1, which is this IP address, and the remote autonomous system what we have got is 100. So let me verify show IP BGP summary. You could see that the neighbor is up here and we are receiving 0 prefixes. So there's nothing getting advertised here, neither we are advertising anything from this router. Let me quickly jump onto router 1 to make sure that the BGP is up. Let me maximize this for a while. Show IP BGP summary. Okay, you could see that I have neighbor relationship with 12.2, which is the link between router 1 and router 2, and link between router 1 and router 4, which means that we have this EBGP neighborship is up, and also we have seen that this IBGP neighbor is up, which is 10.1.12.2. You could see this IP address. We have already found a BGP neighborship. So to test the first scenario, how IBGP is going to process its next hop, we will advertise a route from router 4. This route will be learned on router 1, and router 1 is going to send this route to its IBGP neighbor. Okay, so let's go ahead to and on the router 4. Conf term interface loopback 200. IP address I'm going to configure as 200.0.0.1. Let me give a subnet mask of /24, and I'm going to advertise this route into uh, my BGP network 200.0.0.0 mask 255.255.255.0. Now what I'm doing is on the router 4 I'm advertising this route. So let me just quickly do one more verification. Show IP BGP neighbor 10.1.14.1 advertised routes. Okay, you could see that we are advertising this route from here. Okay, so the next hop shows it's 0000 here because I'm advertising this route from the router 4. It's gonna say it's a 000 because it's originating from this route, this router itself. Now this route is being propagated to router 1. Let's go ahead and quickly verify that. So you could see that when we had executed the command first time on the router 1, okay, so the neighborship is 10.1.14.4, 10.1.14.4. You see that the 0 prefixes were received. Now let's verify. We should see 1 prefix received, and that's right. So we advertising 200 from router 4, which we have learned here. quickly verify show IP BGP. You could see that 200.0.0.0. Okay, it's learned here, and you can notice that the next hop IP address is 10.1.14.4 here. So the next hop IP address is showing 10.1.14.4. Okay, so if I want to reach 200.0.0.1, it is going to send the packet to 10.1.14.4. So far it looks good. 200.0.0.1, and you can see that the packets are reachable. Okay, now the first verification what we need to do is that when this router 1 advertise this route to its IBGP neighbor, what it's gonna do here. Okay, so now this route is getting advertised to router 2. Let's go ahead and verify router 2. Let me clear it up. Show IP BGP summary. Okay, we are receiving one prefix here from router 1. Show IP BGP shows that 200.0.0.0 is learned here, and it's the best path. The next hop is showing as 10.1.12.1, which is correct. Okay, it looks like we have already executed a command next hop self on router 1. Let's quickly verify. Show running section BGP. Okay, that's it. So what we will do is we will quickly remove this command for verification. The fix is already applied here. Okay, let's jump on to this router 2. Without configuring next hop self, it should show that the IP address has 10.1.14.4 as its next hop. So I'll jump on to router 2 again. Quickly verify show IP BGP. You could see that the next hop shows 10.1.14.4. Show IP BGP 200.0.0.0. You could see that 10.1.14.4 is not accessible. I'll go back to the same network here. I am on router 2, and it shows to reach this 200 network, the next hop IP address is showing as 14.4. So I will not be able to reach to this IP address. Okay, so the solution for this is that you need to configure BGP Next Hop self on the router 1. So let's go ahead and do that quickly. So we have proved, we have checked the first thing, how the BGP is going to process its packets. So IBGP, it does not change the next hop. So the solution is that we need to configure the next hop self manually on this router. Let's quickly jump on router 1 and fix this problem. Okay, so I'm gonna jump on to router 1, const t router BGP 100. The neighbor where I'm advertising, it's 10.1.12.2 next hop self. Now you can go back to router 2 and do a quick verification. Okay, you could notice that earlier the next hop was 10.1.14.4, which was not accessible. Now the next hop is 10.1.12.1, and it's working here. This is the valid route, and it's working. When you do a show IP route, you can see that the route it's in this routing table. By this way, we have tested the first setup, or the first thing, how the BGP processes the next hop IP address when it is advertising to IBGP neighbor. Now what we will do is, let me just to work on the second scenario, I'll take a screenshot again. The second scenario is that how it is going to process the EBGP. So when you have some route advertising from router 2, let's say I'm going to advertise 100.0.0.0 from my IBGP, from my autonomous system. So this route gets propagated to router 1, okay, and the router 1 is going to send this packet to EBGP neighbor, okay. So in this case it is automatically change the IP address next hop to its own IP address. So there's no need to apply the next hop self command on this router. There is no need, because BGP protocol processes the packet in such a way that when it advertise a route to its EBGP neighbor, it is going to change the next hop IP address. Okay, so let's go ahead and quickly do the configuration and verify that. So what I'm going to do is I will create a loopback 100 on router 2, show IP interface brief. Okay, interface loopback 100, IP address 100.0.0.1. Okay, so I'm having this IP address now. So let me quickly advertise this network in BGP. Custom router BGP 100, and I'm going to execute network 100.0.0.1 and the mask 100.0.0.0 and the mask 255.255.255.0. This way I'm advertising the route to its BGP neighbors. So let's quickly verify. Show IP BGP summary, show IP BGP neighbor 10.1.12.1 advertised routes. So I just want to make sure that we are advertising this 100 network. So you could notice that as we are advertising this route, the next hop is showing as 000 because it's originating from this router 2. So what's going to happen is when this route reaches to the router 1, it is going to say the next hop is 10.1.12.2. That's fair. So let's go ahead and verify that. Show IP BGP 100.0.0.0. It's learned internally from IBGP, so it is showing as I. The next hop is showing as 10.1.12.2. You could verify that it's 10.1.12.2. Okay, now it is going to advertise the same network to the EBGP neighbor. This is the EBGP neighbor. Okay, and in the EBGP neighbor, it is going to change the next hop to 10.1.14.4. Okay, so let's go ahead and verify that. So let's go to router 4 and verify. Let's go to router 4, show IP BGP. You could see that the next hop IP address is 10.1.14.1, which is this IP address. So there is no need to apply the next hop self command because BGP is going to take care of that. When it is advertising the route to the EBGP neighbor, it's going to use its own IP address or the advertised interface or the outgoing interface. So we have done the verification for both the IBGP, how the BGP is handling the next hop for IBGP and EBGP neighbors. I hope this video is informative to you, and I would like to thank you. You can comment if you have anything to share, or you can, add any comments. If you like this video, you can hit the like button, and you can subscribe to this channel to get more such videos. Thanks a lot for watching. Have a good day.